Okay, so in our last live video, we showed how we make the signs using the Zapper Code and software. We're actually going for something like this, and I should have a blank here somewhere. I guess I do. Okay, so these are the expensive $5 a sheet for the 8x12. I tried to make my own out of bottle caps, but I'm not getting the two color. I was put a plastic bag and it didn't adhere properly, so it kind of came out, but we've got to go back to the drawing board to make our own. But they do work. This is made out of plastic bags, but they don't carve very well, so this is just LDPE plastic bags. This is HDPE bottle caps with an LDPE plastic bag for the second color. Didn't work so well, so we're still using the commercial ones. We did successfully make one out of a 4-inch PVC pipe sprayed with a paint and then carved, so we can use recycled PVC pipes. So we have, we're getting there. Anyway, we're going to set this up and show you how we go about it. So the Xcarve, you have these clamps here, and you have to be sort of careful where you set them up because the machine will grind through them if you don't set it up properly. So what I'm going to do is, and it takes a while, this is the little burden of it, screwing these things in and unscrewing them just takes some time. The blue ones are deeper, the green ones are shallower and are quicker. For the 1/4 inch, we can use the green ones mostly and try to get it bolted down at 4 corners. So there's one here. Since this is already screwed in, I can lift it from my last carve with the blue one, although the blue one takes a lot longer, and just carefully get it right at the edge so it doesn't interfere with the drill bit. So those two sides are clamped down. Now I've got this one here. Again, if you're using the same size, which we're not always, then it takes a little bit less time, you see, because you've already got the clamps more or less in place. Same size of material.
Yeah.
So try to get these clamped down with as little touching as possible, but still somewhat secure. And if you can come around here, you might be able to see it better. And then screw it down. So 4 corners gets it pretty tight. All right, so that's screwed on. Now we open up the software. We turn on the X controller, which we built with our students here. We assembled this Xcarve with our students. It came in pieces, and we put everything together, including the circuit board. And thank God it's working. It hooks up by USB to the computer, and so I type in the password. And then you can see I've already got the software up. Now the software is online software, so you have to have an internet signal, and that's why we have the internet access point over there. So as long as we have an internet signal, then we can get to our projects. And the ones that I did just before in the RV now show up because it is online. So I'm going to be doing today plastic number 5, which is polypropylene, and plastic number 4, which is LDPE, which we have not gotten. We did plastic number 2, so we're done with the HDPE. We did plastic number, let me see, there's one on recycling, but that's plastic number 1 was with PVC. We already did on PVC, so we don't have to carve that one. I didn't carve that on HDPE. This is ironic because this is high density polyethylene, and we made the sign about high density polyethylene on high density polyethylene. This is polyvinyl chloride, and I made the sign on polyvinyl chloride, so that's kind of cute. Number 1, which was PETE, I did earlier, and that one I could not do on PET because plastic bottles, which are PET or polyethylene terephthalate, you can't make signs out of. I tried, they crack, they get brittle, can't melt it, can't heat it. PET is great for making shirts and shoes if you have a good factory that can make spindles out, fibers out of them, but not useful here using the home oven. But so we have number 1, number 2, number 3, and now we're working on number 4 and number 5. So plastic number 4 is this one here. It's going to show up in a second once it gets online and pulls it offline. It says it's waiting. Okay, there it is. This is what it's going to look like when it's made. Note, as I showed before, that the zapper code has to be inverted when you place the scale vector graphic or SVG file in, so that when you carve through the green part of the HDPE, you will expose the white, because the zapper uses white for the zapper code and wants dark colors for the little widgets that define what the code is. So that's critical that you have an inverted image there. Anyway, this will show up green here if it's ready to start talking to the machine. Otherwise, it'll be blue, but it is showed up green, so we're okay. I click here and make sure that I'm at 0.1 millimeters. If I do anything with the Z-axis, never on this machine, never have it be at 1 millimeter. If you do, the machine will not stop. There's a problem with this stopping mechanism, and it could break the machine. So I'd have to hit the stop button. I go slam, stop the thing from working, and then reset up if there was a problem. So I stay on 0.1 inches when I go up. Put my little robot there, and I raise this here the bit, and there we go. And then I take off the dust hood so I can position this. Now, I come over here and I can go to 1 inch for moving it in the X and the Y axis. So I move it over and move it over there. But let me go back first to the middle of the, and I also notice that I really don't want to be here. This is too close to the blade. I'm sorry, to the drill bit. So I'm going to undo this. This looks like it will hold down. It's going to be hard to position my XY. So I'm going to use this little green one. I'm going to come in here and clamp it down. That is keeping this end down, so that is good, but it's keeping this free, this corner. I want that corner free. All right, now I'm going to come over to about the center of this and take my X probe, I'm sorry, my Z probe, not my X probe, my Z probe, plug it in here. Okay, see that there? That goes there, and then there's this clamp that goes on the collar, the black collar down here. See that? Clamp that on, and I put the probe, which is a known dimension, underneath the drill bit. And then I come and go to carve. And I click on carve, measure the material, and it's telling me the exact thickness. I've already measured the exact thickness. We know
It's going out of power.
we know that this is 1/4 of an inch. So that's set. 2-color HDPE is set of all the different options. Confirm the material thickness. Make sure it's secure. Use the right drill bit. Okay, and then you say probe, and then we confirm the position. Clip is attached, and then touch this to here.
But
It
you
says
moved
it's
it.
in place. Huh?
You moved it a bit.
Oh, it doesn't matter. I'll get it underneath. I just wanted to make sure there's electrical connectivity. It tells me that there is. Touch plate is in place, and then I start probing. And then it's going to go down and touch this, and it's going to know where this piece of material is based on the difference that that brass piece tells the computer. So it's saying, where is it, where is it, where is it, where is it, where is it? Oh, it is exactly that many inches below that.
Where is this material on the computer there?
This material? How do you mean?
This point where...
There you go. Oh, the Z probe. Now I put the Z probe away. It talks you through it, and I have to set the X and Y 0. So now I go forward in Y, and I go over in X. I take my metal block and I set it here to make sure that I'm at the right place. I am in the X-axis. For the Y, I still have a few millimeters to go, so that's good there. Now it's touching there, and it's touching here, so I know that it's at that corner. That's how I do it using the block. I set my XY 0 here on the computer, like this, over here. I set it here. I set it here, I set it, and then I go attach dust shoe. So the computer asks me if the dust shoe is attached, so I put the dust shoe on. Because something broke on it, I use this piece of zip tie to hold it in place. And now I place my dust shoe on. It's going like this. Put the vacuum on top of the dust shoe. It's now held by that zip tie, which is good. And now I say, yes, it is attached. Then it says, is the spindle on? So I turn the spindle on. I'm going to try this at about 5 or 5.5 this time. Spindle is on. I say yes. And then I say start. And it is going to, right here on the computer, it is going to simulate the tool pad. And now let's start working. It says it's going to take 3 hours and 19 minutes to finish this car. Over here. It's going to do those halves like that. It's going to take 3 hours and 18 minutes. And it's going to end up like that. That's it for 3 hours. Can you see what it's doing here? And I also need to turn on the vacuum so we don't have this vacuum. And now it's turned on this vacuum. Yeah, go down and wait for me.
We're running out of energy anyway.